This question is asking, consider a pole zero system with system function h of c, and that is given by this. Sketch the regular and transpose direct form 2 realization of the system. Okay, so in order to draw the direct form 2 and the transpose of it, we have to make this one look better. We have to combine all of them together and write it express in such a way that we can identify the zeros and poles easily. So in order to do this one, what we can do is we can multiply these terms. If we do that, then this is going to be 1 times 1, that is 1, and then negative 0.5 times this, negative 0.5 times 1, that's going to be the same thing. But as you can see, 1 times negative 0, so this one happened twice. Only the only difference is e power j5 over 4, and here we have e power minus j5 over 4. So we can take the 0.5 common and add the other two together, like e power j5 over 4 plus e power minus j5 over 4. We are taking this one together because this expression is equivalent to, like, if you have e power j theta and if you have e power minus j theta, that is equivalent to 2 cos theta. So in that way we can simplify this one. And then lastly we multiply this negative 0.5 times negative 0.5, and that's going to give us positive 0.25. And when we multiply, the powers will add, so we are going to have e power j5 over 4 minus j5 over 4. As you can see, this is going to be e power 0, so this is going to be just 1. And in the denominator, exact similar thing. 1 times 1 is going to be 1, and then we have 0.8, and here we have e power j5 over 3 and plus e power minus j5 over 3, and then 0.8 square, which is 0.64, and then e power j5 over 3 minus j5 over 3. Okay, now let's simplify this one. As you can see, these terms can be cancelled because this is e power 0, so which is going to be just 1. And then also I forgot to put the z values. So like here we are multiplying 1 times 1 and then 0.5 times 1, so this is going to be z power minus 1, and since we are adding, it's going to be still z power minus 1 here. And here we are adding z power minus, we are multiplying z power minus 1 with z power minus 1, so here we are going to have a z power minus 2 here. Same thing in the denominator as well. For this one we are going to have a z power minus 1, and this is going to be z power minus 2. Okay, now now we have to know what is cos 5 over 4. Cos 5 over 4 is cos 45 degree. Cos 45 is root 2 by 2. So we can write that one over here. 1, 0.5, and this is 2 cos theta, so we have to multiply this 0.5 by 2 as well. And the cos value is going to be root 2 by 2. And here we will have 0. And z power minus 1 here, and then 0.25 z power minus 2, and in the denominator we are going to have 1 minus 0.8, again 2 cos theta, so we multiply by 2. And then cos 30 degree is 0. Cos 60 degree, actually 180 divided by 3, which is 60 degree. Cos 60 is 0.5, so we are going to have 0.5 here, and then z power minus 1, and then here we have 0.64 z power minus. Okay, so let's look at this one. This is 0.5 times 2, which is 1. So we are going to have this one remaining the same. I bring this one to a next page because I don't have enough space to continue. So this is going to be just 1 minus and 1 times this. So we are going to have 1 minus root 2 by 2 z power minus 1. Z power minus 1 plus 0.25 z power minus 2. And then this is 1.6 times 0.5. Let me double check. 0.8 times 2 is going to be 1.6. 1.6 times 0.5 is going to be half of it, so which means 0.8 again. So this is going to be just 0.8 right here. Z power minus 1 and then 0.64 z power minus 2. So this is our final expression. Now we can start drawing the diagram based on this. So as you can see, we have zeros and poles. When we are doing the transforms, we had to, and also it's mentioned here in the question as well, we had to consider the direct form too. In the direct form too, we know that normally what we do is we take the zeros and poles, and for the zeros the direction will be this, poles the direction will be this, and we will put the coefficient, and for the poles we put the coefficient negative because it's opposite direction. And if we have zeros and poles, we start with 2 plus sign. Okay, and based on what we have in front, that's going to be on top. It's going to be our x of n, and this is our y of n. And if it's 1, this is just 1, we don't have to even mention that. And in the denominator of 1, that 1 here, that we don't have to mention that. And then we have z power minus 1. In direct form, we put all the z power minus 1 in the middle. You can either put d or z power minus 1. Both of them work. Both of them are right. If we put d, we can also put just d as well. So it's going to be d here. And then we're going to put 2 d's because as you can see, we have 2 zeros and 2 poles. So we're going to have, even one of them is 2, we have to put 2 of them. If it's 3, one of them is 3, we have to put another one, like that. So here we have this one, and since I have this now, for regular, the direct form one, we keep the zeros in the right side and poles in the left side. But for the direct form 2, the poles will be on the right side and zeros will be on the left side. And if you look at the poles, we have 2 poles, so I put another plus here. And zeros also same thing, we have 2 zeros, so I put a plus here as well. Okay, and the direction for the poles, as you can see, is going to be this direction. And for the zeros, the direction is going to be this. Same for the bottom one as well. And then we look at the coefficients. So here we have poles here, and for the pole we have root 2 by 2. For the poles, the sign will be opposite. So if it's a negative here, it's going to be positive here. So root 2 by 2, and then this is going to be 0.25, and this is positive 0.25. So we put a negative for this. And for the zeros, we keep the sign as okay, I messed up. I had to look at the poles. Poles are in the denominator. Poles are in the denominator. So poles negative 0.8. So this is going to be positive. Change the sign. And then 0.64, that is positive. So we put a negative for that. And then zeros, we keep the sign as it is. So this is negative root 2 by 2. And then 0.25 here. Okay, and this is our first diagram. This is a direct form 2 regular diagram. Okay, now the next thing is we have to do the transform. In order to do this transform, I bring the same diagram to page. In the transform, what will happen is this plus will be in the middle. So we put a plus in the middle, and then d remains the same. And then this plus will be combined into middle. And then again the d remains the same. But in the third one here we don't have plus for this one, but we put a plus for this one as well. If you have two lines with plus, you put another extra. If it's three, you put another extra, like that. So we end up getting this. And then x of n, y of n, we can keep it as it is. Y of n, we can keep it as it is. And then we have to flip the values. So here, if it's negative root 2 by 2, then I put that one in this side. Be connecting to the pluses. So negative root 2 by 2 will be in this side. And we change the direction of the arrow. So here now that arrow is going toward the left side. Now I change it to right side. Okay. You can do another thing as well. If you don't want to change the values and just want to change the arrows, you can switch this one to x of n, y of n here. Y of n in this side and x of n in this side. And now we change every arrows only. Values remain the same, the arrows only difference. That way you make less mistake. No mistake actually. So currently x of n in y of n this direction, I change the direction of y of n, and x of n is in this direction, so I change the x of n to be this direction right here. I keep the values as it is, 0.8, negative root 2 by 2, and then here negative 0.64, 0.25. The only thing I'm going to change here is the arrow's direction. So if it's this direction, I put it in this direction, and then this direction, this direction, this direction. In that way we don't have to change anything. Like we have to just flip the x of n and y of n. Y of n will be here, x of n will be here. Values remain the same, only the arrows will be opposite direction. And that is our transpose. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.